I'm back. Back again. Let's go to 11.4. A potter's wheel. Alright, so hopefully you guys have the question in front of you. We're going to draw a diagram. Now this one's a little more tricky because they don't give us a picture, but we can do it. Check it out. Good circle, eh? I'm working on my art. That is R. We got our omega. That's the initial. We've got our, remember, it's the rag that's pushing against it, and that is the frictional force, the force of friction. And then we've got this F, this force that's pushing against the wheel to stop it. And we can just put I right there. So, essentially what we've got, what we're looking at, is it asks for the mu of k, which they call the coefficient of kinetic friction. Now, we know that is in this equation, which says force of friction equals mu of k times normal force, right? So essentially, you're just saying, okay, how do I get this mu of k using these two? Well, guess what? These two equal different things. Well, in a certain sense, because this, remember, force, any force is equal to a mass times acceleration. So we can just manipulate these guys, and we're going to find our answer. So what we do is, we know, first we'll start out with, I'll write that real quick, N. What is N equal to? It means the contact force, and they essentially give it to us right here. This force is pushing on this guy, and it's contact. You're taking that wet rag or whatever it is, and you're trying to stop this potter's wheel. And for mine, it's 62.8 newtons. Oops, big N, right? So I'm just going to take this F and plug it in there. So we know F. So that part's solved. Equals MA. Now M, there's a fun little equation that M is involved in. M is equal to I over R squared. Now I probably should have written this before, but they give us the R. They give us the radius. And I got 0.561 equals R. They also give us the moment of, what is it called? The moment of inertia. Where is it at? Moment of inertia, 12.5. So, if I is equal to 12.5, all we're really dealing with is to solve for M, all we really got to do is plug this in, R squared, and then I, and we've got our answer. So what I actually like to do is go I over R squared. We just kind of make it look easier because we've got this number, we've got this number, we've got this number. Now we just need to find a number for A. If we can do that, we're good. A is actually equal to, this acceleration is equal to this alpha times R. R is radius. This is angular acceleration. Now, how do we solve that? That is a good question. We've got what's called an equation. And you need this bad boy because it's going to give you this angular acceleration. You've got the omega, which is, sorry, that's A. and the omega is angular velocity. So they give us the final, omega final. What is it? It's 0, right? Hold on, I'm going to draw this out first. So your equation is this. Omega final equals omega initial plus alpha t, right? So all you're going to do is essentially plug these in. We know they give us the time, and look at your time. You can pause the video, do whatever you need to find your time. Anytime I usually go pretty quick, or I just say, you know, just kind of cruise through it. Usually it's information that they've given you. I'm going to start trying to write it down beforehand, but tonight I've had to kind of cruise through it. So time is what? 5.315. That's what they gave me. This, remember, we're solving for this guy, so he's just going to stay acceleration. Plus, what is the angular velocity, the initial? And I got 5.62. And then this is 0. So it's just essentially algebra now. You solve for theta. And I got, or not theta, alpha. And my answer was 0.3129. I believe so. Okay, so essentially you're like, well, how the heck was this 5.62? And what you have to do is you have to do make some changes. So they give you 53.7 revolutions per minute, but the problem is omega, or angular velocity, is always in radians per second. So take whatever that number you had there. I had 53.7 revolutions per minute, and do some dimensional analysis. It's kind of a fancy word I like to use. So 2 pi radians. So to change revolutions into radians, you just take revolutions, you put 1 revolution is equal to 2 pi radians. And so these revolutions can cancel out. And you also want to multiply minutes. 1 minute is equal to 60 seconds. And you get your answer, and I got 5.62. Right? It's that one. Plug that in. Solve for theta. Take theta. Alpha. You've got alpha, you've got your radius. So now you just plug it back up in here. So all you're doing is just solving for these different numbers. You've got alpha, you've got radius. So you know your radius, they give it to you. You know your alpha, you solve for it down here. You plug that in there. You know your moment of inertia, 12.5. There. You know your radius again, make sure you square it. And you know your F, your force, is right there. All you got to do is multiply all these up, divide by F, which is your force, and you get mu of K. And that's it. Hopefully that helped. Hopefully you followed. Watch the video again if you need to. And yeah, cool. See ya.